So today's notes are on rearranging formulas, and we're going to start by just quickly going over what is a formula, just to make sure we're all on the same page. You probably could give me an example of a formula, and I'll give you a couple of examples right now. So probably the most common one might be area. So we know like area equals length times width. There's also distance equals the rate or the speed times the time. So D equals RT. These are two examples of formulas. So what is a formula? So first of all, it is a relationship between variables. But it's also, we think about formulas when we're using formulas in applications of math and science. And when you get to physics, there will be a ton of physics formulas. Okay, so now our big idea of our lesson for today is that we can rearrange the variables in a formula using our same equation solving techniques that we've been using for equations and inequalities. So let's write that down. We can rearrange formulas Oh, actually, I meant to say we can rearrange variables in a formula. Using our same equation solving techniques. So we're going to look at a couple of examples in this video of formulas and how we can rearrange the variables in them. And the way we're going to kind of start to think about that is by also looking at a related equation to each of the formulas. So if you notice in this chart, it says equation with more than one variable, and the first one is ax minus b equals c. We're solving for that x right there. Well, if we look at the related equation, we have 2x minus 6 is equal to 10. We're still trying to solve for the x. We just have numbers in the place of those other variables. So we have 2, 6, and 10 instead of a, b, and c. And we're going to solve these two kind of side by side to kind of look at the process between the two of them. Okay, so if we first look at the related equation, 2x minus 6 is equal to 10. The first thing we're going to do here is we'd add the 6 over to the other side, right? So we add. Well, then I would have 2x is equal to 16, right? So now I'm going to go over to my equation with more than one variable and think about doing the exact same first step. So instead of adding 6 to both sides, though, in this one I'm going to add b to both sides to get the b over to the other side. So these two b's will cancel. I'll be left with just ax on my left-hand side. And on my right-hand side, c plus b, I can't actually combine c and b because they're not like terms. So all I can do is write c plus b here. And again, our first step in both was to add. Now, if I come back over to the related equation, 2x equals 16, to completely get the x by itself, I'd need to divide both sides by 2. The 2's would cancel. I'd get x equals 8. In my equation with more than one variable, I'm still trying to get x by itself, and in this case, x is being multiplied times a. So to get x by itself, I have to divide by a to both sides. On the left, the a's cancel. I'm left with just an x. And on the right-hand side, we have c plus b over a. I can't do anything to simplify that because those are all different variables. So there's no like combining of like terms I can do. So the only thing I can do is just kind of leave the right-hand side exactly as it is and say x equals c plus b all over a. But if you notice, we did the same two steps. We added, and then in this last step here, I divided, right? So really, the process is the same. It just, sometimes you're not going to be able to combine and simplify the same way you can when you're solving an equation with numerical coefficients. In this next example, we're still solving for x. The equation is a little bit more complex. We have ax plus b is equal to d minus cx. So we have x's on both sides. So then I have a parallel equation or a related equation that is 3x plus 4 is equal to 6 minus 5x. And we're still trying to solve for x there. So I'm going to start by looking at the related equation, and I know I want to get my x's all on one side. So I'm going to add 5x over to the other side. And I'm going to write out a step that I don't usually write out, but it's going to help us kind of see the relationship between the two equations. So instead of immediately combining 5x with 3x and getting 8x, I'm first going to just write them next to each other. So write 3x plus 5x plus 4 is equal to 6. Okay? Now if I come back over to my equation with more than one variable, I would add the cx term over to the other side. And I get ax plus cx plus b is equal to d. Okay, so coming back over to the related equation where we have this 3x plus 5x, so we know we need to combine like terms. We know it's going to equal 8x, but I'm going to do it in a way that I use the distributive property. So remember that both of these two terms have an x in common. So I could rewrite this as x times the quantity 3 plus 5, just using the distributive property, right? I could multiply that x back in and get back up to the previous line of the equation. And then from there I'm saying plus the 4 above is equal to 6. Okay, I want to do this same thing with my equation with more than one variable. So they both have that x right there. I'm going to factor that x out. So I'm just going to write x, and then in parentheses, what's left over is the a and the c, the a plus the c. So then I have a plus c in parentheses plus b is equal to d. Okay. In my related equation, of course, I know that 3 plus 5 is 8, so this becomes 8x plus 4 is equal to 6. I can't simplify a plus c in the same way I can simplify 3 plus 5 because a and c are not like terms, so I'm just going to leave it in parentheses. Okay, so now in my related equation, the next step would be to subtract the 4 over, and I get 8x equals 2. In my equation with variables, I'd subtract the b over. So let me just record what we did. We did subtraction right here. Okay, and we're doing subtraction here as well. Kind of running out of space to write my steps. So again, those b's are canceling. I'm left with x and times a plus c is equal to d minus b. I can't combine, so I'm just going to rewrite d minus b. Okay, the last step in the related equation would be to divide. And I'd get x equals 1/4. And in my other equation, I'm going to divide as well. It's going to feel a little weird, but I can do it. I'm going to divide by a plus c, because that's going to cancel that a plus c out, and I'm just going to be left with an x. And here, I just have an a plus c on the bottom. So that my final solved formula looks like x equals d minus b over a plus c. And just to make sure I record, like the last step was to divide right here, right? And then my final answer, I'm just going to box these for clarity. We have this one and we have this one.